Hey everyone, and welcome to today's Explainer. Today, we're diving into a massive shift that is literally redefining technology as we know it. We're rapidly moving away from the era where artificial intelligence was just some localized software running quietly on a server. Instead, we're accelerating toward a future characterized by an unbelievable cosmic level of energy demand. We're going to explore how highly specialized intelligence is scaling up, how it integrates right into our global defense networks, and ultimately how AI powers modern data centers, or honestly, how it's completely overpowering them, pushing us to look beyond our own planet just to keep the lights on.
So here's our roadmap for today. We're going to start by meeting the AI specialists, then we'll check out the global intelligence network, trace the legacy of British innovation, confront the AI energy bottleneck, and finally, look at the wild idea of powering AI from space.
All right, Section 1, meet the AI specialists, the new titans. To really understand our technological future, we have to start at the micro level and look at the models themselves.
You know, we used to always look for that one single best artificial intelligence that could just do absolutely everything. Well, that era is completely over. We've shifted away from generalist tools to a brand new generation of what you could call titans. Each of these flagship models excels as a highly tuned specialist with its own distinct performance persona. Today, you don't just pick an AI, you deploy the exact right specialist for your specific job.
It's really like a giant puzzle where every piece has a clear, distinct division of labor. Take Gemini 3 Pro, for example. This is your versatile communicator. It scores an impressive 81% on the MMU Pro benchmark for multimodal understanding, so it's amazing at interpreting charts and video content. Then you've got Claude Opus 4.5, your dedicated engineering specialist, hitting 80.9% on the SW bench. That means it's incredibly good at actually building and shipping complex, real-world software. And finally, there's GPT 5.2, which is engineered for pure abstract reasoning and novel problem-solving, pulling a 54.2% on the intensely difficult ArcAGI 2 verified benchmark. By splitting up these tasks, we can route incredibly complex problems to the exact model designed to solve them.
Moving on to Section 2, the Global Intelligence Network and Defense Strategy. Let's see how these highly specialized agents are actually building into real-world applications of international security.
In an increasingly complex world, Britain's intelligence response is evolving at breakneck speed. Deep inside the command center at RAF Whiting's Pathfinder building, there's this massive global intelligence hub that's actively reacting to a 50% increase in hostile activity against UK defense. We're talking about everything from espionage and cyber attacks to electronic warfare from state actors. This facility brings together defense, counterintelligence, and military intelligence services to deliver faster, much clearer responses to these rising, highly sophisticated threats.
But RAF Whiting definitely doesn't operate in a vacuum. It acts as a vital node in the Five Eyes Alliance. This is a deeply integrated intelligence-sharing partnership between the UK, the United States, Canada, Australia, and New Zealand. Having this unified structure allows for the rapid, secure exchange of data regarding global threats. By leveraging the advanced AI data processing capabilities we were just talking about, this alliance integrates intelligence from the Navy, Army, Air Force, and Space Command. It absolutely ensures future conflict readiness across the entire globe.
Section 3, a legacy of innovation, British design. Because honestly, to truly grasp the scale of these modern tech hotspots and global intelligence hubs, we have to recognize the historical foundation they're built on. This stuff doesn't just appear out of nowhere.
British design and tech have consistently shaped the modern world through a long legacy of world-changing innovations. You can trace this right from the 19th century revolution of everyday transport with high-speed rail, all the way into the 1980s when pioneering hardware brought affordable home computing to the masses with really innovative keyboard designs. Fast forward to the 21st century, and we're seeing advanced structural engineering techniques that enable the construction of Europe's tallest skyscrapers. It's this continuous thread, identifying a massive societal need and engineering a robust world-class solution to fix it.
Which brings us to Section 4, the AI energy bottleneck and data center limits. All of this relentless innovation, global networking, and specialization leads us straight into a massive, looming crisis.
We really need to talk about how AI powers modern data centers, or more accurately, how it is entirely overpowering them. Right now, global AI demand is experiencing roughly 100 times growth. The computational needs required to run massive models like Claude Opus or GPT 5.2 at a global scale are exponentially outpacing our traditional terrestrial energy infrastructure. Modern data centers are being pushed to their absolute physical limits just to supply the raw electricity needed for these specialized AI calculations.
To put that into perspective, just look at the glowing thermal reality of a massive data center facility in Rockdale, Texas. The deep reds and oranges on thermal scans represent immense heat signatures. AI processing runs so incredibly hot and requires so much continuous electrical load that just cooling these sprawling facilities has become an absolute engineering nightmare. Data centers are generating a shocking amount of heat, creating a severe physical and energetic bottleneck right here on Earth. We are, quite literally, running out of space and power grid capacity to keep our intelligence scaling.
So, what's the fix? Section 5. Powering AI from space, the next frontier. If we can't build enough power plants on Earth to fuel these data centers without melting the grid, we have to look up. The next frontier of technology involves a highly ambitious, kind of mind-bending three-stage roadmap. Step 1 is orbital scalability, proposing the deployment of AI compute hardware directly into Earth's orbit, where it can be powered continuously by clean, unfiltered solar energy. Step 2 takes us even further with the vision of a lunar industrial complex. We're talking about establishing moon-based factories to build more satellites and AI hardware using rocket-free launch systems. And finally, Step 3 aims for true civilization-level scale, targeting over 100 terawatts per year of space compute to drive continued, uninhibited advancement. We are literally talking about moving the data center into the vacuum of space.
And the crazy thing is, this isn't just science fiction anymore. It's the active pursuit of modern innovation hotspots right now. Regions like the Oxford-Cambridge Arc, which is a globally recognized center for science and technology, and Greater Manchester Tech are actively driving the AI discoveries that will enable this massive leap. They are drawing up the blueprints today to transition from Earth-bound servers to a vast space-based infrastructure.
We are witnessing the evolution of artificial intelligence from simple chat interfaces on our smartphones into hyper-specialized, incredibly potent entities powered by the cosmos itself. The sheer aesthetic and functional reality of this shift is totally surreal. We are unbinding our most powerful minds from the thermal and energetic constraints of Earth. Our ultimate goal here is a beautifully surreal future where humanity seamlessly integrates with off-world infrastructure. By harvesting the energy of the stars to power our synthetic intelligence, we open the door to limitless technological advancement. We are stepping firmly onto the path of becoming a true Type 2 civilization. So I want to leave you with this final, provocative thought to ponder today. Once we solve this terrestrial energy bottleneck, once we are successfully powering our AI from the limitless energy of space, what impossible problem will we ask these new titans to solve for us next? Thank you so much for joining me on this explainer, and I absolutely can't wait to explore the next frontier with you.